The Hack Week that's coming up will involve, some project work that we'll be collaborating on together. And while I have some of you here, I just wanted to mention that our goal is to get people thinking about projects early in the process. And so we'll be posting on that shortly around how we can start to pitch some ideas. And it helps if we can do that in advance on Slack. We'll have a separate channel going for that. So just wanted you to start thinking about some projects that you might want to bring to the Hack Week. It could be, if you're a graduate student, some work that you're doing in relation to that. We'll provide a list of all the different ideas that you might want to focus on in a project, but just to kind of plant that idea in your head early in the process, and we'll hopefully get some conversations going on that soon. Another thing is the Jupyter Hub that you are using for these lessons, these software carpentry lessons, will continue to be running throughout the month and into the Hack Week, of course. And just wanted to let you know that you can continue to use those resources. Scott made a post on this yesterday that if you do use them, be sure to log out, and it then shuts down that instance, saves us on some of the fees that are associated with running these resources. Well, we've got three folks today, Scott, Katie, and Evi, who are going to be sharing the teaching of basic Python skills today. And I'm going to hand it over to Scott Henderson. Scott is a research scientist at the University of Washington, my colleague at the Science Institute. And among many other things, Scott has been responsible for deploying all these Jupyter Hub resources and keeping track of deploying that for large groups. It's been a really important piece of the work that we're doing. So really grateful for Scott's work on this to provide all this cyber infrastructure for these Hack Weeks. And Scott's going to start us off today. So I'll hand it over to you, Scott.
Well, thanks, Anthony, and good morning, everyone. I think we've got critical mass, at least, of participants today. So yeah, we'll jump in, and hopefully some more folks will join. We have 3 hours this morning to go over intro to Python. And so the goal is going to be teaching some fundamentals and recapping and reviewing using Jupyter Hub, Jupyter Lab to run Python programs today. So we won't get through all of it. I just want to make sure right off the bat, everyone's aware that this is too much content to cover it's too much to cover the full lesson in 3 hours. But what we're trying to do today is give you a good head start, answer questions, and then hopefully you'll be able to explore this material a bit more in depth on your own time before the Hack Week. So yesterday we learned how to log on to the Jupyter Hub. We also saw how to navigate this Jupyter Lab interface, in particular, opening a terminal and navigating a computer through a terminal. And then finally, we learned using Git for version control. So there's a lot of content yesterday, and we will use a little bit of it today. We're going to be using the same Jupyter Hub. So hopefully folks can log on. It often takes a few minutes to set that up. So let me share my screen and make sure people can see that. Can I just maybe get a thumbs up or emoji hand raise from folks? Cool. I see at least a couple thumbs up there. Yeah, perfect. Yeah, I'll try. If you're comfortable turning on your video, feel free. If not, we'll just go with these emojis to get some feedback. Obviously, it's different running these lessons in a classroom than on Zoom, and it's too bad we can't be together today, but we'll make this work. So we are, just a second here. Okay. So on the SnowEx Hack Week website, hopefully you all have this page bookmarked now. This is the software carpentry training schedule that we saw yesterday. There's a link to the Jupyter Hub here, snowex.hackweek.io. So I've opened that up in another tab in my web browser here, and encourage you all to do that now. Just wanted to point out that we're at day 2. So we're going to try and stick to this schedule as closely as possible, taking some breaks every hour and switching up who's talking and what we're talking about. But we're using the software carpentry lesson linked here under the day 2 schedule. So you might want to open that up as well. Plotting and programming in Python. So this lesson has a couple links at the top on setup, which we're not going to go over today because that's setting up Jupyter Lab to run on your own laptop. So you can do that later on, but today all you need to do is open our SnowEx Hackweek.io Jupyter Hub, and you'll have Jupyter Lab pre-installed, running, ready to go. So that's the interface we see here. So Jupyter Lab, to put things into context, is the graphical interface we use to write programs and navigate a computer. It's very similar to a MATLAB interface if you're accustomed to that. People often think that it's specific to Python, but it's actually not. So Jupyter is this cross-language effort to develop computing tools. The name stands for, it's actually a merging of 3 different programming languages to form the name, Julia, Python, and R. So this Jupyter effort was designed to make tools that work with all these different languages that people are using to program. And Jupyter Lab is just the interface that we use in a web browser to run these programs and interact with the computer. So if you run this on your laptop, you'll see a browser that looks just like this. The difference here is that we're running on a server instead of running on our laptop, but the interface is exactly the same. And that's what Jupyter Lab is. It's this browser-based interface. All right, so today, yeah, I'm pretty excited to teach people Python if you have not used it before, which we're assuming. It's a fantastic programming language. It's open source, freely available, so you can download it, use it wherever you want. It's widely used, so there's just a tremendous number of libraries out there and resources for scientific data analysis that you can benefit from. So once you learn a bit of Python, there's so many existing tools, and it's such a broad ecosystem of software libraries that you can use that are free and open source based on Python. It's really worth your time to learn this language and invest a bit of time in understanding how it works. So, so to start, if you click on this topics 1 to 3 link on our schedule, those topic numbers are listed here in this schedule table. So we'll start off with this running and quitting section of the software carpentry lesson. And as I mentioned before, a little bit of this, if you follow the instructions word for word, relate to running things on your laptop, but once you've opened this interface, it'll be the same. I'm also going to be kind of looking up because I have 2 monitors going on. So yeah, just bear with me here for a second. Okay, so getting started with Jupyter Lab. Usually you would open a terminal on your laptop and type the commands like we were doing yesterday with the commands ls, pwd. You could type the commands Jupyter Lab and you'd open this interface. As I mentioned, we already have it running on this server, so you don't have to actually launch Jupyter Lab. It is launched for you when you log on to our SnowEx.Hackweek.io. So we saw a little bit of this yesterday, but just to reorient people to this interface, there are a couple features that are pointed out in this first lesson. First of all, we have a menu bar up at the top. So you'll find different ways to change the default view. You'll see under this menu options for running. That corresponds to Python programs. We'll see that in a minute. Settings, you can change the font sizes if things are too small, too big. You can change to a dark versus a light theme. There's a lot to explore here in terms of customizations of what you see. On the left, this is a key panel of this interface. You have a file browser. So you'll probably see more files here on my screen because I've been using this Jupyter Hub and creating files and things that you don't have on your server, but you'll see your files over here in your home directory. You can double click these files to open them up. So I have a file here, readme.txt. If I double click that, it opens in our area to the right. So you can edit text files, close them. So this is just like a file browser on your left. You can hide this panel if you want more space in one area, the folder up here in the left, file browser. If you click on that, that file browser disappears. So some aspects of this interface are really intuitive, others maybe not the first time you've seen it. If you want that back, you need to click on this folder icon, and that brings back this file browser. So yeah, that's the file browser. There's some other tools here that we're not really going to go into. I think all you'll need is this file browser tab today. If you want to create a Python script, you can do a number of things. On the right-hand side here, we see this tab called Launcher. You have options here, different buttons to click. Under Notebook, you should see one of these tabs, Python 3. That would open a Jupyter Notebook. You also have options down at the bottom to open different utilities like the terminal we used yesterday, text file, markdown file. So a Python program, just like MATLAB scripts or R scripts, is just a text file. So the way you could create a Python script is clicking on this text file button, and you could type a Python command in this text file, and then file, save text as, and typically Python files are named with a .py extension. So you could call this whatever you want, Python script.py. And when you save a file with that .py, it's still just a text file, but a lot of editors will recognize the syntax as a Python program and do highlighting of the syntax for you. That's why you see this in green now. So that's one approach to creating a Python script. Today, we're going to be using Jupyter Notebooks to do our programming. And Jupyter Notebook is an alternative to this .py. Maybe if I could do another emoji poll or raised hands for those of you that have the videos. See, has everyone written or seen a Python notebook, Jupyter Notebook in the past? All right, so maybe half of folks have come across these before. That's great. So to launch a new Jupyter Notebook, to create a new one, which is what we'll do for this lesson, the easiest way is to click on this Python 3 logo under Notebook. You can also go up to File, New, and then you have those same options from your file menu. So we could say File, New, Notebook, or click on this Python 3. That opens a new tab. And here again, we have the file name, and we just get the automatic name untitled1.ipynb. So again, this is a file format that conventionally ends with this .ipynb for the file name. And in the software carpentry lesson, they describe kind of in detail how it's stored, et cetera, behind the scenes. It's a text file. Again, it's stored in a format called JSON, and then this Jupyter Lab interface is able to render it in a nice way in your web browser. We don't really need to know how it's stored behind the scenes. We just want to use this to write Python programs. So I encourage you all to save this notebook with an informative name. We don't want to call it Untitled1. So we'll save as, and you can maybe call it software, oops, I don't know. So you can go to save as, you can also right click on the top tab, and there's an option to rename notebook. I'm going to do that. Software Carpentry .ipynb. And then you'll see that over in your file browser as well, whatever name you just picked. All right, so we can write both Python code and text in this Jupyter notebook. And this is why these have become so popular, really, is that you can mix text with what's called markup. So you can do headings, you can do equations, you can embed figures, and then you can also write code that's executable, functions and everything. So it's really nice for communicating results of your analysis, because you can mix and match different content types. And I'll show how that works now. So you'll see the cursor here is in what's called a cell of the Jupyter notebook. And this cell is set up to write code. The way you know that is at the top here, in this top menu bar, you have some options shown, and this one pull down menu at the center has code selected. If you click on that pull down menu, you have some other options, raw or markdown. Often Jupyter notebooks at the very top will start with a markdown cell. So you can change these between, is it code, is it markdown? Markdown is a type of text formatting that uses some simple markup to format how the text appears on the screen in a web browser. So let me just demonstrate how that works. If we select markdown, you'll see that kind of bracket disappeared on the left. I'll show that again. So I'll go back to code. I have this kind of square bracket and column. If I switch to markdown, that's gone. So now we're typing markdown. And again, the software carpentry lesson has a lot of content on what different tricks and different types of formatting you can do with markdown. One of the key ones is the number sign, which creates a title for you. So if I typed without that number sign, software carpentry Python in this cell, you'll see it just looks like text at this point. If we run this cell, it will be formatted using markdown. You can run cells with the little play symbol at the top here. You can go up to this other top level file menu, and there's a run selected cells option. Most oftenly, you start using keyboard commands to navigate this interface, and you'll see under run, run selected cells, there's this up arrow enter. So that's shift enter to run the selected cell. So let's try that. If I do shift enter, what just happens? I ran that top cell, and then I got a new cell below it to type new things, and automatically you'll see that this new cell is a code cell. So again, your default cell type is code. It's for writing Python code. Now, if we go back to the first cell, you'll see that this formatting is just text. It's just a unformatted text. You can double click on existing cells to edit them. So now we're back to this first one. And if I add a number sign, you'll see that this just turned blue. This is because it's markdown, it's recognizing markdown for rendering. So all I've done is add a $sign in front of Software Carpentry, and now shift enter. And you'll see that when that ran, that got rendered as a title. So Markdown is really nice for formatting these documents quickly. If you're used to a text editor, like going up and finding options for bold or italic, that's sort of what you're doing, but you're just using code-like shortcuts to do it. So you can also do things like lists. You can add bullet points. I'm just typing some random things in here, but you'll see, I've put in these two asterisks to make a bullet point list. So do that. So that's pretty nice for communicating what you're going to do in a notebook, is having a top cell that's marked down before you start writing code. And again, I'm just going to switch back over to this lesson, make this text a bit bigger. And if you want to go over more details of what you can do with Markdown, this is in this first running and quitting section. Towards the bottom is where we're at. Command and edit modes, and Markdown into pre-printed documentation. So that's all I'm going to show here. You can do a lot more. But finally, let's just look at how to write a code with Python, and then move on to getting into Python syntax. So back to our notebook. Here we have a code cell, and so we can, let's just see what happens if we do the math suggested in this software carpentry lesson. So we type 7 times 3. At its most basic, you can use Python as a simple calculator, right? You have started a notebook here, and the syntax is what you expect. An asterisk for multiplication. You could do a minus sign, plus for subtraction, addition. So let's go ahead and do a 7 times 3 in this code cell. Shift enter to run it. And to see when we run a code cell, we get an output that's the result of your computation, or the result of the code that you've run. So 7 times 3 is 21. Okay. So that's a whirlwind tour of this interface. Hopefully put some context into what Jupyter Lab is, what these Jupyter notebooks are that we're currently running, and then Markdown and Python code. So that's lesson 1. And let's go ahead and just keep moving. to the second lesson, which deals with variables and assignment in Python. And the goal of this second lesson is to learn how you store data and what different data types exist in Python. You can keep using this same notebook. If you want, you can also practice creating new notebooks for each sub lesson here. All right. So again, we didn't cover every single thing in this interface for Jupyter Lab, but these bottom arrow keys in the software carpentry lesson down here will move you to the next lesson. And here we're on variables and assignment. All right, so we're going to look at how do you assign variables. In the first cell we just wrote, all we did was type computation, but we didn't store a variable. We just did 7 times 3 and looked at our output. And now, what if you want to store this result so that you can reference it, functions, and other computations? The way you do that in Python is just with a single equals sign. So age equals 42. And if we run this cell, actually, before running that, I failed to mention one thing. With these cells, Shift-Enter will run what you've written. If you just press return or enter on your keyboard, you get a new line. So that's important to remember. If you've already run this cell, just remember you can click back into it in order to continue to edit. So after age here, we want to actually store 2 things in a single cell. So after age equals 42, you can hit return and say first underscore name equals Ahmed. So now we have 2 lines storing 2 different variables. And again, this can be in one cell, it can be separated into multiple cells. Shift enter, and you'll see there's no output here. Above, we got the output of 21, but now we don't have any output because we've taken these numbers and stored them in 2 different variables. Age equals 42 and first name is Ahmed. So there are some rules in terms of how variables are named. One thing we talked about yesterday is don't use spaces. The same is true with Python variables. That's why you'll often see underscores used in place of spaces. So here we have first underscore name. It's also important to realize that variables are case sensitive. So if you have a capital F or a capital A, that's important when you refer to these variables later on. So what if we want to display a variable? This is where Python's print function comes into play. Print is built into the Python language. So we can use this function in any Python program or Jupyter notebook. And we're going to say print first name. We can use commas to separate what we're printing. So first name, comma, the string is the variable age, and then we'll say years old. And now we get an output because print gives you an output for your cell. So now we see Ahmed is 42 years old. So this is a nice way to format strings with variables. You can combine multiple in a single print statement to do the formatting that you want. Okay, so what happens if we try to use a variable that doesn't yet exist? Up above, we did first name, and we meant to do last name, but we didn't get around to it yet. We forgot to create this variable. And if you try and print that, Python gives you an error. Usually errors with Python are very informative, which is nice. They kind of tell you what's wrong rather than just saying error. So that's huge. And in this case, we see name error, last name is not defined. So that just means that this last name variable has not been defined yet, and therefore Python doesn't know how to print it. So definitely, whenever you get these errors, it's fine with Python. You get errors all the time because you forget to write something. You just overlook something. So read these carefully, and usually you'll figure out pretty quickly what it is that, in this case, I forgot last name. Yeah, this is pretty important. The order of execution can get a little confusing with Jupyter notebooks. What happens if we type last name? I'm going to use my own last name here in the cell below where we just ran that print statement. So now I've created that variable. And you can see this number on the left here corresponds to what cell has been run. So this is the sixth cell that I've run. Up above, we still see this name error. Previous cells don't rerun themselves, I guess, when you create a new cell. And that's very important to realize with these this cell-based approach to programming. So if you go back up to 5 and rerun this, we no longer get an error because now last name has been defined, and these variables persist across cells in your notebook, but those cells aren't automatically rerun. So you'll see what's confusing here is now our numbers are out of order if you're going from top to bottom. I have 1, 3, 4, 7, 6. So I've been running these cells in different orders, and it's easy to do this, but it can get confusing if you're kind of jumping around a lot. So one strategy I use in my own work to try and avoid this, and it's quite easy to overwrite variables when you're doing this, jumping around, is if you have a simple notebook like this, you can always go up to the top and say to the kernel menu. Kernel is kind of just another name for whatever Python or programming language you currently have running. So under kernel, you can say restart kernel and run all cells. That's very handy. So we can do this, restart and run all. And what will happen here? We just reran the cells top to bottom in the order that they're written. And again, here we see this name error. So really, you should define this last name up above. Another feature of these Jupyter Lab interface is that you can drag notebook cells to different orders. So I can click on last name on the left, and you can see that if I click and hold and drag, I can move these cells around. So I can put last name up there before our print statement, and then go to kernel, restart kernel and run all cells. Now we don't get that error because our variable's defined before the print statement. So that kind of keeps things in order if you want to do that. All right, variables and calculations. We can also use these variables we've defined in numerical calculations. So we say age equals age plus 3, and then print age in 3 years. I do encourage you to type along as we're going through these lessons, just to get the practice of doing that rather than watching. So there we've just added 3 years to age, and we've stored it. We've overwritten the previous value of age. You can also index Python variables. So the way indexing is done, this also depends on language. sometimes languages use different types of parentheses to do this. In Python, you use square brackets to index. So atom underscore name equals helium. What if you want to get the first letter? Atom underscore name 0 is going to give you the first letter in Python. This is another thing that trips people up initially when learning Python, coming from another language, is that indexing starts at 0 instead of 1, which a lot of folks are accustomed to. So to get the first letter, square brackets 0 gives you the starting one. You can do slicing of strings. So instead of atom name 0, we can do atom name 0:3. And this is called a slice. It's going to give us from 0 to the third value. Actually, they want us to use sodium now. So atom name equals sodium. This is also something that tends to trip people up with indexing in Python. The last value is inclusive. So we start at 0, it's not inclusive. So we go to the third spot, which is going to be the first 3 letters. So it's actually 0, 1, 2, 3, right? Gives you up to the third letter. And you can see that with your output, which is SOD. So this might seem straightforward, but there's a lot of subtleties in the way indexing is done in Python. And if you're new to it, yeah, just pay attention to how these slicing, what letters you get back from these slices. Okay, so let's see here. In the interest of time, I think that I will go ahead and wrap up our final lesson today. I think we've seen the key things here with assigning variables and extracting from these strings. So we will go ahead and just move on here. Again, look through some of these practices later on, practice exercises to get a feel for what you can do and just practice if you haven't seen this before. But we'll spend just a couple minutes going over data types and type conversion, and then have a break here this morning. Okay, so far we've seen a couple different variables, and each variable may not be obvious from what we've written so far, but different variables have types in Python. So up here, we have atom name equals sodium in quotes. And so that is a string in Python. And we've also used numbers up above. So we've used age equals 42, for example. In addition to print, there's another built-in command in Python, which is type. If you're ever unsure what a certain variable is it a string, is it an integer, you can use type to figure that out. So if we say, for example, print type 52, we see the output is class int. Int stands for integer. Similarly, for a string, if we say print, we have I'm just gonna say fitness average, print type fitness. Now our variable fitness is defined as the string average. And so we see class str, again, is an abbreviation for string. So type's important because different operations can only be done on certain variable types. For example, mathematical operations, print 5 minus 3, we get the answer there. We're subtracting 2 integers. But what happens if you try to subtract strings in Python? So something like this maybe seems intuitive. You can try to subtract that first H from hello. Maybe you want to alter your string that way. There we see, again, it's a pretty informative error in Python, unsupported operands for minus sign, string, and string. It's a little more confusing, but what this is saying is you can't use this subtraction operation on a string and a string. You cannot subtract strings. But what you can do is you can add strings together. So for example, full name equals Ahmed plus, we'll use the plus operation, and we'll add 2 quotes just as a space, and then Walsh. Someone asked in the Slack, and please do either unmute and ask questions or just type questions in the software carpentry questions. Why wrap a print statement around type? You don't have to, but in a Jupyter notebook, if it's the last cell, you automatically print whatever that operation is. So for example, if I just do type in the cell I'm writing here, type full name, you also get an output without the print statement. But what happens if you have a cell with a lot of inputs? Let's say I also want to do a subtraction in the cell 5 minus 3. You're only getting the output from that the last line in a cell in Jupyter Notebooks. So print can make sure that you print whatever you need in your output. So if I wrap type full name in a print statement up here, I get that output, and I also get the output of the last line in the cell. All right. Cool. Yeah. So another thing, in addition to addition, you can try some different operators. Again, we're using this same kind of mathematical operations here on different variable types. But if you try separator, sorry. You'll notice this works. You can combine a multiplication of a string and an integer in Python. It's just going to reproduce this string however many times. So in this case, 10 equal signs. There are also other built-in operations in Python that apply to certain variable types. So the len stands for length. You can do length on a variable. Here you'll see, again, an informative error message. Separator is not defined. So I clearly have a typo there, which I can fix. Separator. I think I misspelled it earlier. And you'll see the length of a string of this variable string is 10. But if you try and do the length of a number, you get an error. An integer has no length. So I think that communicates the main idea of certain operations are valid. You can multiply a string and an integer. You can't subtract 2 strings. There are these rules of the language that allow you to do one thing or another. So we'll take a break there, 5-minute break. That was quite a bit of content. Get up and stretch, ask questions if you have any, and then we'll return to some more Python content. All right, so there's one question in the Slack channel. Does the Ipython notebook save automatically when we restart a kernel and run all cells? Similar to how MATLAB always saves when you run the code. So to answer that, yes, this notebook is saved automatically as we're running cells. I can close this. Let's say I close this notebook, software carpentry.ipynd. Close out. Back to this launcher window. You can see though that file is over here. If I open it back up, I still have my outputs. You can also, if you're ever in doubt, click this save edits, save notebook contents and create checkpoint. I want to make sure it saves right now. So you click this little disk button up here, or go up to file, save notebook. And that guarantees that you've saved right there. If I go up to kernel, restart kernel, you'll notice that just restarts the Python interface, but our outputs are still there. We didn't do the clear all outputs and run. So again, if we save this, close it, those outputs are still there. Kernel, restart kernel and clear all outputs. If we do that, we no longer have these outputs from our cells. And you'll see the next time I open up this notebook, those are gone. So there are options for clearing this, but as you type and as you run cells, it is automatically saved. So again, I haven't clicked this save button over here and just ran that cell. Here I'm getting prompted because it hasn't auto-saved yet. It auto-saves on some frequency, and I can hit save before closing. And then, is there a window where I can see all saved variables currently in my environment, similar to RStudio? That's a good question. Does anyone know the answer to that?
I think you can download a plugin for it, but it's not inherent in the Jupyter Notebook platform.
Okay. Well, yeah, there's no built-in option to do that. I think one thing you can do, let me just run a few of these cells. You can also insert new cells. So if I go edit, this is something we didn't see before. I don't know where it is in the menu, but clicking on this plus button here is going to add a cell underneath the one we're at. There are some shortcuts which we haven't gone over yet in a Jupyter Notebook with Python. These percent symbols are called magic commands. And if I run that, I think that's coming from MATLAB actually, if I remember right. Maybe RStudio has the same thing. You can see a summary of all the variables you have in your current session. So that could be helpful if that's what you're looking for. All right, and then one other question, under what circumstances would I use a text file to execute Python code instead of a notebook? What are the limitations of a notebook? So I find that notebooks are especially convenient for communicating results or for interactive exploration. And a Python script is sometimes when you have a function, you're doing something very repetitively, and you want to run like a command in a terminal over and over again. That's kind of where this Python script comes into play, versus a notebook is very much a visual document that you want to interact with visually. Python script is where you might run things in an automated way. Cool, yeah, keep the questions coming. Hopefully folks had a bit of a break. Yeah, I'll turn it over. I think Katie, you're going to take these next few sections, right?
Yep, and I'm going to share my screen now.
Oh yeah, sorry, I think I'm walking that, aren't I?
Great. Okay, so should we give folks a couple more minutes, or should I go ahead and get started?
Maybe one more minute.
Okay, great.
Oh yeah, and please, if you're, have already seen this or have the answer to other people's questions on Slack, please do answer. We really want participants and everyone to chime in. So yeah, I encourage you to do that.
All right, I'll go ahead and get started. So Scott just talked about the different data types that we have in Python and how different data types have different characteristics. So now I'm going to jump into functions and some of the built-in functions in Python. And there, we'll go into more. There's a ton of different functions that you can use in Python. These are the ones that come when you download Python or opening Jupyter for the first time. These are some of the things that you can do. And if you're following along in the on the GitHub page, we're on the section 4. So we're just the overall things that we want to use is how can we use these functions, and some of the errors to expect, and just some of the different ones that you could use. And then later on, we'll talk about how you can load in even more functions into your Python Jupyter notebook. So one thing to also note that Scott might have mentioned, so he talked about the formatting. I just copy and pasted some of the stuff from the GitHub page into this Jupyter notebook as a way to help people, in case I have a hard time switching back and forth between screens, but you can see just some of the different ways that I formatted this notebook. Another example of just essentially using a lot of different hashtag signs and bullet points. So you can make things look really pretty. And like Scott said, when you want to run your markdown and make it look into a pretty paragraph, you just hit Shift Enter, and then it pops up there. So just trying to connect those dots and help people get a feel for how to interpret these notebooks. But one of the other things to mention when we're talking about built-in functions is this use of commenting. So Scott mentioned using Markdown and how you can write things normally. It's not running, the Python's not interpreting it like code. It just is interpreting it as text. And then it's a really great way to explain the code. If you want to write something directly into a coding cell, you can use, if you were to write just a normal sentence, like this is a comment, into a coding cell and try and run that, Python's going to think it's code. And so ahead of that, you're going to want to put a hashtag, and then when you try and run it, Python ignores it. So you can then, especially if you're writing a lot of code and you're trying to set yourself reminders of what certain things do, you can start mixing code and comment together. So you could set a variable into a code cell and then add a comment here of what the cell does. And then Python won't interpret it as code. It will know to ignore it. So if you're new to Python, just want to give some basics of some of the different functions. You've already seen one of the functions that you'll use a lot already, and that's the print function. So if you're following along and typing on your own computer, print, it shows up as green. Python knows that it's a function. If you want to print a word, you can start using that function. You can link functions together. So you can even just print like an empty space, or you could add like a string space if you wanted to do that too. And then you could even add a word at the end, and Python will print all those out. The other thing to note is that Python, every function has to return something, and sometimes that doesn't make like a whole lot of sense. So in this first line here, we have a variable that's setting the output of a function, which Python's going to get kind of confused on. This is kind of a small point. This is an example of not good code. So if you try and print the result of, let's just see if we can even just scrap the string at the beginning. If you try and print this result, it's going to print it, but it's also going to return a none because that's a special value. So some of the other built-in functions that Python has are max, min, and round. And these are really helpful if you're going through like a big table and you want to know what's the max in your column. So again, if you're typing up at home, you can start practicing different ways to use max and min. So again, I'll use our print function. We can combine some of these functions too. So you can print the max of a set of numbers. So for example, if I wanted to find the max of, let's say, like a few numbers, so 1, 2, and 3, it's going to return the largest of these 3 values. So I'm going to pause there and just see if people are if people want to return a few thumbs up to see if that makes sense of just starting to see how these functions work of returning an output from a set of inputs. Okay, I'm seeing 1 thumbs up, so that's pretty good. The other thing that is built in is the min function. So if we wanted to print the min of this same list of numbers, if you're following along at home, just try typing print and then min of 1, 2, and 3. And instead of 3, it's going to return the lowest number. So if we just want to look at the min, we can do it that. We can put a comment on our first line and then just return the min. Max, min, and round, these also can do the max and min of strings too, and it just returns like the lowest number in the alphabet. So if you're trying to find the max or min of a word of a mixture of characters and numbers, you could do the min of, let's see, we could do a few numbers, or a few letters, I should say, B and C. And in this case, if you guys have any ideas, you can start to predict the min of A, B, and C. Python knows that the order of the letters in the alphabet, and it will tell you that the lowest is A. If you start mixing numbers in here too, it will put like 0 comes before the numbers in the alphabet. So 0 would be first. So that's just a bit of background about some of these built-in functions. Some of the other things to note is that they always, some of these functions like need at least 1 argument. So unlike the print function, which didn't need an argument, if you try and do that for, let's see, max, max, it's going to return an error. Same thing with min. If there's like kind of a weird set of numbers that it doesn't, if you're mixing string and numbers, for example, and so you try and put 1 and then the letter A, then it will also give you an error. So that's just some of the things to note if you're working with max and min. If you see some of these, if you see these errors, not supported instances of string and integers, some of the things you might want to look for in your code is, am I mixing like a number and a letter? So if you're working in tables, maybe accidentally your numbers are being treated as characters, then another place they're being treated as numbers. So these are just some of the things to look out for that Python will complain about. One of the other built-in functions is the round function, and some of its key characteristics is that it will round off. It will take a floating point, which Scott mentioned earlier is a number with a decimal place. So a number like 2.4. And if you round it, it rounds to 0 decimal places. So it brings it down to 2. And if we want to do, we could even start integrating some of our lessons from last time, and we could even figure out the type of this. And it took it from a floating number to an integer. So we talked about the differences between floating points and integers, and how floating points have decimal points and take up a little bit more memory, and integers don't. So if you're trying to work with different data types and you're rounding different numbers, keep in mind that if you're rounding something with a decimal point, it will go from being a floating point to an integer. Round is also useful if you're working with significant digits, because you can start to what's the word I'm looking for? You can start to specify the number of significant digits that you need. So if you're working with data next week in SnowEx, and you have something that has like GPS points that has like a lot of decimal points at the end, but you really only want like the first 3, you can start to specify the significant digits by adding this second number after round. And this second number here, so this first number is our input, 58.86, and then this second number is the number that we want it to round to, and that returns a 58.869. So I'll pause there for a second. Just a reminder, the 4 built-in functions that we've just talked about are print, max, min, and round. So I'll just, if people have questions about those, feel free to stick those in the Slack channel. We've got some helpers that can answer those, or feel free to chime in here if it's something you need clarification on, and feel free to put up a thumbs up just so I can know that we're following along. The key takeaways are that these functions need inputs, and then they return an output, and they're really useful ways. Instead of having to do these things by hand or investigating, you can look at a ton of data and use these functions to really quickly get the answer that you're looking for. All right. Okay, we'll spend just, we've got a few, we're gonna keep moving and keep moving down, and we've got a little bit more content to go through, and then we've got one other section to breeze through. So one of the other things, we'll talk a little bit more about this once you start to work with different functions from different libraries, so things that you load into Python, but sometimes a function has to have a certain method attached to it. So this is a little bit more advanced, but you can start to, if you specify a variable. So in this case, and I've typed up the code because this one was a little bit heftier, but if you start with a string and then you want to print the, let's see, you want to print the length of your string. So that's what length does. That's, let's see, let's actually break this down. So if this will be the last thing for this section, and then we'll jump to libraries. But if you have a string that you've specified, so here we have hello world, and one function that you can do that is find the length of it, and that's using len. And that tells you that there's 12 characters. And then one thing you can do when you're using functions is to do what's called a method, and that's doing a specific action item to the, in this case, the variable. So we've got our string, and then if we want to call a method onto it, we're doing swap case, and let's go ahead and see what that does. And it switches the lowercase to uppercase. So there's a lot of different functions that you can do onto your variables, but the takeaway for now is to get used to this syntax right here, which is you adding a period and then adding the function afterwards. The other thing that's kind of unique about this is it's this open and close parentheses. And so that is telling the code, let's see if we take it, it might be easier to see. Oh, never mind. I was going to see if it popped up in a different color. But that's telling Python that this is a function here. So there's a lot of different things that you can do. You'll see sometimes if you have a data table, another really common one, this is a little bit more advanced now. We don't have a table loaded in, but if you just want to get the top few rows of a data table, you'll do like dot head and then the open and close parentheses. But we won't go into that now. You'll just see this a lot more. So we just want to plant the seed. I'll go through and then we'll move on to the next section. But one other way, if you want to get to the help, get more help on your functions, you can type in help. Let's see, help, and then round, or and that will give you a little bit more background. You can do help.max. So you can play around with this and try and get more information. The other thing that you can do is if you have a function, you can do on your keyboard at home, Shift Tab, and it will tell you a little bit more information, or you can put a question mark after it. Oops, I don't know why that type the function name instead of the question mark. Then I don't know why that didn't work, but there's a few different ways that you can get help on these functions. So I'll move on to the next section, but before that, just keep in mind that Python also tells you different errors. So we have a syntax error, which is if you forget like a quote at the end of your variable. So here we're specifying a string and we've forgotten to add the quote here. So this would look right, but this is it wrong. And it will tell you that there's an error. And same thing, if you've forgotten a parentheses, it will tell you it's actually a different type of error called a runtime error. And that's when it's trying to interpret the function, it's getting stuck because the function's actually being inappropriately written while it's trying to be executed. So now below we have the exercises, and I'll let you, I highly recommend you all doing those on your own. Again, that's at the link on the GitHub page. But now we'll switch over to libraries and just take a 1-second pause to let people catch their breath if they're working with a notebook, and you want to comment in that this is now the library section. But now that we've talked about functions that are built in, this is a way to get functions that are not built in. Python, if you look online, this is the part where coders tend to just Google a lot if there's something that you want to do in Python. There's probably a library out there that will do the thing that you want to do. So SnowEx next week, we'll talk a lot more about the really common libraries. There's Pandas and Matplot and scikit-learn. These are all some of the really common ones, but we're going to use the library today for this exercise. It's a library called math. So just to back up here 1 second, just a little bit more about libraries. One way that you can think about a library is that they all, like each library will have like a certain set of functions built in that can do like a lot of tasks that tend to be related to one another. So there's some libraries that are really good for plotting data. There's some libraries that are really good for data tables. So when you're thinking about, okay, I'm writing code, what are the different things that I want to do, and what are the different libraries that I'll need to write the code that I want to write? So at the beginning of a Python script, you'll see a lot of people at the very beginning, it's common practice that they'll just import the libraries that they need. So for example, you might import math. I'm just going to put in some of the ones that I tend to import a lot. These are the some of the very common libraries, and the important word is the word import. And Python's actually pulling these libraries in, and then they'll be in your notebook, and then you can call functions from these libraries. So if you were to ignore these libraries, but just try and call a function from that library without importing it first, Python wouldn't know where it is and wouldn't recognize the function. So the first step is to always import the library. So for example, let's see, we'll restart the kernel so you can see what it looks like without importing the library. So let's say we want to use this library math, but we didn't import it. So we're going to pretend that we didn't import it. And we want to use pi. And we've looked up on the internet. We're like, okay, we want to use pi for a certain calculation, but we've forgotten to import. The library math. If we just try and run pi, Python won't recognize it. But if you import math first, and then you type in math, print math.py, Python now knows where to find pi in the library math, and then it will print out your pi value. And so you could set this to a variable, and then they use this in your calculations. But it's really important that you call the library first. If you just tried to call pi, let's see, let's put that in a different cell. If you just tried to call pi on its own, Python wouldn't recognize it. There's a step that you have to do before that we'll talk a little bit about later on, if you want to use pi on its own without specifying math.py. So going back to just getting help and like using these functions and knowing what you're doing as you're doing it, the help function works here as well. In addition to, we talked about how you can do help.round if you want to look up a function, help on a function. If you want to look up a whole library, you could do help on math, and then it will tell you here are all the functions that are built in. And so if there's a library that you're working with and you're trying to figure out, is there something that you want to do? Let's say you're working with, it looks like this one's doing a lot of math calculations. If you're working with something that you want to figure out the cosine of, but you don't know the exact function name for, maybe they call it COS, maybe they use the whole word cosine, you could read this documentation to get the exact function that you want to know about. And then the other thing about working with libraries and the syntax is if you want to use specific parts of that library without having to use in this case, we talked about how if you wanted to use pi, you had to use math.py, but let's say you just want to use the word pi. The trick is to, go from math. So not import, you just use the word from, but then from math, you import the word pi. And now if instead of using math.py, I can scrap the first part math and just use the word pi. So this makes your code a little bit shorter. If you're going to be using the word pi a lot in your code, maybe you want to just ignore, forget having to write math the whole first time. So sometimes this makes your code a little less readable, because if you just have the word pi, people might forget that it came from the library math. And if you have a lot of different libraries, they might not know exactly where you found it. But this is one, you might just be aware that you might see this in code too. And the keyword there is the word from. So the other thing about libraries is that you can shorten, if let's say you're tired of using the word math.py, but you also don't want to just use the word pi, because you don't want it to be, you want your code to still be readable. You could import your library and give it a shorter name. So one thing that you'll see is the word as after the word import. And so it will say import math as m. And now if you do m.py, it will return the variable of interest. So these are all the different things that you can do with libraries. You'll see a lot more libraries later on in some of the other sections. Down below, we have a few exercises, but I'll just pause here and give people a second to ask questions in the chat. And let me check now if you see. Oh, okay. So someone's asking, how do you look at the helper function like swap case? Seem to work, but do work for things like max and round? Yeah, that's a good question for swap case, since it's one of those special. So sorry, I'll read the whole question out loud. This is one of the questions in the Slack channel. Thank you for the question. We've got, let's see. Okay, looks like we've actually got a handful of questions. Let me start. Okay, let's see. So if we might need a couple, there's a couple helpers. I want to make sure. Oh, it looks like we've got some replies. This is awesome. Okay. Oh, great. So thank you, helpers,
call on us, Katie, if you want us to jump in.
Yeah. So are there any questions? Let's see. So we've got, like a few minutes left. Are there any questions in particular that the helpers think we should highlight, that I maybe should talk about with the group that I didn't go over clearly enough? Yeah, let's see. I'm trying to look through some of the replies now to make sure that they're all answered.
Yes, Scott or Evi, are there any we want to elevate to the rest of the group? These are great questions.
There's one request actually, Katie, to increase the text size on the screen.
Oh, sure. Yeah, let's see that.
But otherwise, yeah, no, just keep the questions coming on the Slack channel. I think there's some examples of, yeah, the different ways of looking at help on a function. But I don't know, Katie, did you want to speak to any of them in particular, or just?
Let's see. Looks like, yeah. Oh, go ahead.
There's one unanswered question. There's one unanswered question. The last one: how do you install, download new packages that are not already included in the SnowEx instance?
I think we may delay answering that one. Well, yeah, if you're familiar with using Conda or pip, these are Python package managers. So from a terminal, you can install packages that way, but it will take a bit of time to go over how to do that today. So I think I will put some answers on the Slack, but I don't think we'll take time to answer it in the lesson.
And I believe that most of the packages that we'll use for this period and also the hack week have already been installed by Scott, so we might not need that. But if we do, we can just use the magic line with pip install the package name. But yeah, I believe we already have all of them installed.
Great. Well, Scott, if there's a bit of extra time, we could do, there's exercises that we could, I could post in the chat, and we could have folks go into breakout rooms and do some of the exercises. What do you think is best?
I think that'd be great. Yeah.
Great.
I have a quick question. So with the mass function, how that different from NumPy function? Can you?
Yeah, that's a great question. So this question is the max function, which in this case takes the max of like a set of numbers. There's another library. So there's another library called NumPy. So I'll actually just leave the longhand that also has a max function, and let's just go ahead and look at the help function. Oops. Sending
That
output.
max.
Oh yeah.
That's max, yeah.
There we go. If we want to look at the differences between them, and if we want to, so let's see. So we get a little bit more. Yeah, my understanding, and maybe one of the helpers can give a little bit more detail, is that they, for simple cases, so we did NumPy dot max 2, 3, and then they would be the same, but I'll let one of the helpers answer if they've had any circumstances where they would return anything different. Oops. And now I'm getting an error on that. Okay, so it looks like NumPy has a more specific set of inputs. Yeah, just does any of the helpers have a experience? I haven't used NumPy max as often as I've just used regular max.
Yeah, I think NumPy operates on arrays. So if you put square brackets around those numbers, we'll treat it as a list, and that should give you an output with open parenthesis before the first square bracket. So just to the right after the X of max, open parenthesis for the
right.
Yeah, that should do it.
There we go.
Yeah. But a key thing, I guess, is that NumPy is an additional library. It's not built into the core Python programming language, whereas max is. So if you're just working with basic Python, you might not have NumPy installed, and that would be kind of the main reason with the basic max function.
Basically, is regular mass function work with the list, and NumPy work with the array. Is that way it works?
NumPy basically has its own data type, which are ND arrays or NumPy arrays, and normal Python, for normal Python, we just use lists. Some people might tell you that the max function might be faster with NumPy if you have like really large values, but I don't really know how. I don't really know if that really applies for simple function like max, but generally NumPy arrays are usually faster for computations.
Thank you.
Yeah.
I have a question about importing libraries. I guess are they stored somewhere within the Conda build, or are you reaching out to the internet each time that you import? So would that sort of prohibit if you were in the field and you were trying to script something up and you didn't have a internet connection? Are you left with only fundamental Python commands?
When you try to import, you must first have installed it. So you can't really import something you don't already have in your system. But if you need to install something, you actually need like a connection or somehow have it saved in your computer to install. So usually, if you have like a Conda environment installed, you can use the Conda install. but then you also need the internet, or you could just use the pip install, but you still need the internet to install, if you don't already have it in your system.
Okay, so there's
Sorry.
2 steps. There's install before you leave home, and then
Yeah.
import every time you write a script.
Yeah, so you'd have to anticipate the libraries that you would need in the field. These pip and conda that we're referring to are package managers, just ways of conveniently combining different libraries, because there are dependencies between these libraries and they need to talk to each other. And conda and pip are ways to do that more seamlessly. So we've already created this environment that you're working with in Jupyter Hub, anticipating all the libraries that you'll need for the Hack Week. But if someone comes along, say on a project, and needs a more obscure package that we haven't installed, you won't be able to run it. You would have to get us to go back and load that in, or there are various different ways to approach that. But yeah, if you're needing a library that you don't currently have in your existing environment, you would have to have that internet connection.
Cool. That's what I thought. I just want to make sure.
Hey, I have another libraries question. I'm coming from an R background where you don't have to implicitly call the library name or the package name every time. So like to make a function or something so you don't have to call the library name in front of it, do you have to do it as the from import to something? Because like I see them, a lot of scripts, they shorten NumPy as NP or matplotlib as plot. And is that just because it's less characters for them to type, so they don't have to type matplotlib every time they want to call a function from that library?
So the thing is, like we just saw like moments back, some libraries have like we have the maths library has like the max function, and NumPy also has the max function. Most times these functions return exactly the same thing, but it's possible in some cases it returns different results. For instance, I think if you try to maybe find kurtosis, it is something in statistics for using maybe SciPy library, it returns a different value when you try to use NumPy. One returns like, if you try to maybe do something like I think correlation, one uses Pearson's method, the other uses a different method. So it depends on what you want to achieve or what you are trying to look for. You might need to specify the library you want to use that from. Does that answer your question?
Yeah, I just it seems like every time you call a function from NumPy, you then have to put NumPy in front of it with the dot. That's like syntax in Python. Okay.
Yeah.
Cool.
Yeah, and Jack, that is like, I guess, considered the best practice so that you don't overwrite functions accidentally. You always know exactly where they're coming from. But if you're just doing some like interactive exploring, you can do from NumPy import star, and then everything gets imported like you would have an R, and you don't have to do the prefix. But I wouldn't recommend that, just because you can do tab completes to fill out the names in the Jupyter Lab. And so, it can seem annoying to type every time, but if you do the tab complete, it's actually quite quick.
Yeah, I totally see why they do it. It's just an adjustment for me coming from a different background of having to call it every time, but it makes your script much more clear where you could debug them because you know exactly where the function's coming from.
Great. Well, if there are more questions, feel free to chime in here or put them in the Slack channel. Thank you again to all the helpers for answering all these questions. Do we have enough time for breakout groups? Great.
Where are we at?
how to use these built-in functions. So the first step would be, if you're trying to look this up, you can do help in math. Sometimes you can just Google like math library and Google into Google. But if you were doing this on your own, you would do help and then look up the library that you want to look up. And underneath the file, underneath the output, it has this list of functions that it has. So you could have looked through here and noticed that in this case, let's see, where is it? All the way down. This library does have a square root function, but there's other ways. And one other theme in coding is that I shouldn't say always, because that's a hard statement, but most of the time there's multiple different ways to do what you want to do. So if you were thinking about this problem and you wanted to calculate the square root of 4, you could have used the square root function. Oops, I forgot to use math. You could have done the square root like the built-in function, but let's say you wanted to do use a different function instead, you could use the power function. So that would be another different way. And then this looks like just like a calculator where you're raising it to a certain power. So if we're trying to find the power of the 4 to the power of 0.05, this would be the syntax for that input. So this is the number that you want to find the square root of, and then what is in that like exponent placeholder, and you get the same output. So takeaways are that you can always use the help function, and there's multiple different ways to do that. So the second question was, why does the square root exist? And this just has a little bit more history about Python. Is that this comes from, actually, I learned this today too, was the origin of the math library comes from another language called C, and that includes both the square root and the power function. So these got built in as kind of a legacy of some of these older functions. But then to go over the other question, and now we're at our break, so I'll just wrap this up here. But if you were filling in, if you're doing this at home, the different ways that you could fill in this code, if you looked here, you noticed that the word bases was being used, but they didn't declare it anywhere before the code. So bases goes here, and then down here, you could really put in any variable, but you could do like index or something like that. And then it's just giving you the output. And so, oops, and bases. Oh, right, because it needs the, it wanted, my bad. It wanted and bases to be declared here. And this needs to be IDX, and this needs to be IDX. Oops, and bases. Oh, wait, did I miss a line? Okay, wait a second. Random, oh, here we go, IDX. So you can declare, I messed that up. Now it should work. Oh, oops. Okay, we'll take a break here. I'll fix this code. I messed this up, but I'll let folks take a break. Feel free to, I messed up the order of the code here, but feel free to take a break if you need to, and let me, let's see. I messed the code up in the original one, but we'll take a break here and then reconvene at 11, but then there we go. So I messed up the order. This should be in the wrong order, but anyways, so yeah, that was my bad on that exercise. So sorry if people got stuck there, but length of all these letters and then rearranging them and storing the output here. And then the basis is just finding the output. Anyways, we'll reconvene at 11 and give folks a chance to take a break. Obviously, my brain's a little bit tired too.
Okay, there we go. All right,
Okay.
Welcome back, everyone. Evi is going to lead us through this final section here for the last hour.
Okay, I'll just go ahead to share my screen. Okay, so in this section we'll be looking at Python lists, then for loops, conditional statements, and writing our own function. Katie, in the last section, you showed us how we could use Python inbuilt functions. So to start off with lists, basically we use lists when we try to store, multiple values into one single variable. So I will start off with creating a list of, say, depths. Maybe you want to, maybe you run an experiment, or you have you run an experiment, or you're doing a study and you have a list of snow depths. So we create a list by just, writing the variable name that you want to use for that list, and we enclose the elements of that list in a square brackets. So here I'm just going to put arbitrary values for snow depth, just any values. And so yeah, we have a list of different snow depths, right? And once we create our list, we can perform like a variety of functions we can call variety of methods on the variables. For instance, I could, start by just printing depths as it is, just printing depths, and we can see the different depth values in our variable. I could also maybe print the length of this of depths, which basically returns the number of elements or items in this list. There are other functions that we could call, or there are other methods we could call for depths. And to just find what those other methods are, we could simply do help, like we've seen before. We could just do help, and we'll see a variety of functions we can actually call on a list. We could sort it, we could reverse it, we could insert something, we could extend it. These are just different Python functions we could call on a given list. Now, the next thing we'll look at is how to maybe fetch an item from, okay, I'll just increase hope this is better. So the next thing we'll look at is to fetch an item from a list. So if we want to fetch an item from a list, we do that by simply just, using the index of that. We do that by using the index of that item we'd like to fetch. So if I want to fetch the item at this position, I would do that by just saying depth at 1. The reason I'm using 1 is because, as Scott earlier told us, Python indexing starts at 0. So even when we have this at like the second position, because Python indexing starts at 0, I'm just going to know that this is 0 and this is 1. So if I run this cell, I'm just going to run all the cell again. If I run this cell, you'll see that it will retrieve the value at this point. Now, also, if I run we can see that the length of this list is 8. The length of this list is 8 because it has 8 items in this list. However, if I try to run like depths and want to retrieve the 8th element and I use 8, we'll find out that would have an error because the list index is out of range. That again because our list starts at Python indexing starts at 0 and not 1. So that's something we need to be careful about. Another way of retrieving the last item on a list is, instead of trying to use the number itself, you could just say -1 or -1, and when we do that, it retrieves the last item on the list. And if we want to move from that direction, we can go on to say -2, and it just goes back to just keeps moving by just using the negative sign. So that's just basically how we can, index or locate a particular item in a list. Now, furthermore, we can maybe want to assign an item in a list to a particular variable. So to do that, all we just basically need to do is just to say, maybe we could just say the fifth item. So this variable is called fifth item. Then I could just assign depth at 4 to it. So if I need that fifth item, I could just say fifth item, and I run it. It gives me the fifth item on this in this list. So that's how we just simply, assign variables to items in a list. Other things we could do to this list is to say, maybe try to sort the lists. So the sort function is one of the functions that, or one of the methods that we have in our list. So to do that, all I just basically need to do is to say, is to call up our list of depths and call sort. Now, when I do this, if we try to look at our depths again, we would see that our depths have been sorted, from the list to the largest depths. But there are some times that we might want to say, maybe sort them in from the largest to the smallest. So to do that, I can simply just check for help of this sort function, or I will check for help of Python lists, because depth is a list. I could just search for depth of I could search for depth of the help for depths, and then I could see all the the method I can call on depths. I can also still do this with just saying lists, right? Like we have seen before, and it's exactly the same thing. So if we go back, don't go down to like the sort function, we could see that it has a key, an argument we could define here, like the reverse. So which is by default set to false, and that is what it has done. It did not reverse this depth. So if I want the sorting to be from the largest to the smallest, then I would call reverse. I would call it reverse, and I'll make it true. So this way, if I sort this, it comes from the largest to the smallest. And there are a lot of other functions we could call on a list from here. So that's next we can concatenate two lists together. We can append new items to a list by using different methods. So first, I'm going to look at the append method of just adding a new item to a list. So if I need to add a new depth to this list of depths, I could just say depth dot append. Then I could add a new depth, say 2000. And once I run that, if I try to view my list again, I would see that it has appended, it appends 2000 to the end of the list. Alternatively, but there are some other cases where I might want to put this new depth in a specific position, right? In this case, I want to put it at maybe the third element or the fourth element. Then I can assign I could just assign I could assign to depth 3 because I want to depth 3 because I want to change the fourth element to something else. I could assign to depth 3 maybe a number 800. And when I do that, if I run my list again, if I try to look at the list again, I will find out that at this position now we no longer have 365, we will now have 800. So basically this is just assigning a new element to a specific position in a list. Now we could also maybe want to add two lists together. One of the very easy ways. So I have this list of prime numbers. So I call this one prime, and I call this one team prime, and I call this one middle age prime. So if I want to add these lists, maybe the prime number, the prime and team prime together, one very crude way to do it is just to say prime plus team prime. If I do this, I would have, both of them merge together. But the proper way to actually do this is actually to use the extend, which is prime dot extend. Then I can extend team prime. So first I'm going to run prime so that we'll just see what prime is. It's still just the first, these first four numbers. But if I run this before that and extend prime, then prime, adds both the prime and the team prime numbers. That's one of the advantages of using the extend. If we try to say use append for this function, say I say prime dot append. If I say prime dot append and I try to append mid h prime, we would find that what happens here is that it appends mid h prime to the end of this list, but it just appends it as an item, just one item, right? And not individual members of the list. So we would see here that if I try to maybe, assess the last item in the prime, I would see that it would give me that whole list of mid h prime, and not 39. So we should take note of this. If we want to maybe add a new list to an existing list, we should, use extend instead of using append. Append is just for like adding a singular element to the end of a list. So those are just basically some things we could do with lists. Like I said earlier, we could try to look at the help for list, and we'll see we would see different functions or different things we can call on a list. Like we've used the length. I believe we've used length, and I also believe we've used append. And we also use extend. Okay, yeah, we've not tried the index, but this is something I would also see in like the next topics. And yeah, we could also like reverse a list, and of course we've tried to use the sorts. So I'm just going to pause here just in case we have any questions. Okay, so I think it's safe to move to for loops. Now, so looking at for loops, just going to erase this. So there are times where we want to repeat a task or make our program do many things. So basically, a crude way to just do it is to just do it by hand. Of course, that's painstaking. Or we could just simply make our program just do it for us by iterating over a list. So I have this list of depth again from the last time. And if I print this, it just simply gives me that list of depth. Now, assuming that we want to specify that this depth is actually, say, in meters, one way I could do it is, of course, creating a new list, but this time ensuring that I put M on meters at the end of each number. But that would be time consuming. So, but I could easily just do that with a for loop. So the way a for loop is written is just to like say, have an instruction of how you want to iterate over a list or whatever you want to iterate and what you want to do at the end. So basically, I'm just going to say for, using the keyword for each depth in the list of depths, right? I could say, okay, first I'm going to create an empty list. because I don't want to change my depth list, I'm going to create an empty list, but this, I'm going to call this list, empty list depths in meters, right? Equal to just close brackets, which is, this is just an empty list. So now I'm going to say for depths in depths, what you're going to do for me, it's you are going to, I could create the arbitrary variable, just maybe value is equal to depth plus a string m for just meters, so that it adds for each of the, you know, depth value, it adds m at the end, and then it assigns. So next I will do is to assign using the append, and I'll just say depth in meters dot append this value. So every time it's going to go around this list and append this new depth plus m to depth in meters. Now, if I run this, I'm going to run into error. That's because I tried to concatenate an integer plus a string. So to avoid something like this, I'm just going to, force depth to be string. That way I have depth as string and also have m as string. And if I run this, I could now see, if I try to view depth again, depth in meters again, I would see that it has added m to all of the elements of that list. So just by just writing a for loop, I don't have to, go over this list to type, to create it again. I just simply just write a few lines of code and I'm able to return each element, with meters. This is particularly useful if we have like a very, very large data set, right? That's maybe it's like 1,000 item, 1,000 unit long. Now, another way to iterate over a list is using the range function, right? So the range function is another inbuilt function in Python. How this works simply is just by saying range, and then you can specify, you can either give it one argument, you can give it or two arguments, or you could give it 3 arguments. Now, whenever we give a range like one argument, say I give it an argument, say 10, and I run this, it will just give me a range from 0 to 10. I'm just going to put a list here so that it can list out all the range. It gives us a range from 0 to 10. But this does not include 10 itself. So if I actually want a range of 0 to 10, I'm just going to make this say 11. Now I have a range from 0 to 10. Now, so whenever we impute just one, we give just the range just one argument, it assumes that as the end of the range and starts from 0 up to that amount, up to that point. Alternatively, I could give the range function, say 1, 10. Now, what this does is that it tells it start from 1 up to 10. Of course, it won't include the last element. If I change this to 5, it just does it from 5 to 9. Now, the last one I would look at is, giving it more like 3 arguments. Now, when we give it 3 arguments, the first argument would be the start, the last argument would be the stop, and the second argument will be the stop, and the last argument will be the step. So I'm going to just use a step of 2. By default, the step is 1, so I'm going to use a step of 2 here. And if I run this, you see it just gives me even numbers between 2 to 20. So using this, I could also like iterate over a list. I could also like go through a list by saying something like 4. Again, I'm going to use the 4. Okay, I'm going to repeat the same thing, but now I'm going to use like the 4. So I'm going to say 4. I could use any value, any iterator, say I in range. I could say range 10, or 8. Again, I'm going to just go back to my depth to just, check the exact value of the length of this. And that is 8. Okay, good. So I could say for I in range 8, right? The problem with this is that sometimes we might get this wrong if we're not careful. So for best practice, I would just prefer to use just the length of depth. That way I'm never wrong, because I'm never wrong, and I would not go to, go out of range when I try to iterate. That's the beauty of trying to dynamically assigning the range length. So I could just say for I in range, the length of the depth, you could do a particular function, say, maybe adds 5 to each of those elements. So again, I could say I could have depth plus, okay, I could call this one depth 5, which means I'm going to add 5 into each of these elements. So what I would just simply do is that I will just say depth. Sorry. So I can say value is equal to depth depth I plus 5. So I'm adding 5 to each element in this depth. Now we can see that we notice difference here between this method and this method, because I have deliberately indexed with this iterator, because I'm using an iterator here. And I can again also append, and I append the new value to this depth 5. And if I view depth 5 again, I'm going to see that for each of my depths, okay, let me just call depth here so that we could see both of them. So you would see that 5 has been added to each of these elements in the, in my depth list. So that's just, one way of using, for loops to go over a list, and just automatically automate some processes we might want to automate. We can also do something like accumulation, right? We could use a for loop to maybe perform adding numbers from 1 to 100, or maybe try or multiplying two to each consecutive numbers. So to try to demonstrate adding numbers, say from 1 to 100, or the first 10 integers, I could just first of all create a value as call it sum of 1 to 10. The reason I can't just use something like sum here is because sum is an inbuilt Python function, so it wouldn't let me use it. So I could just say sum of numbers, and I could set the initial value to say 0. Then I could write a for loop that just basically adds for I in range 10. I could just ask it to add all the numbers in that range. So I could just say sum of numbers equal to sum of numbers plus 1, right? So at the end, if I print sum of numbers, I would see the sum of numbers from 1 to 10. But this, doing it like this, I might not get the, correct answer. And that is because remember that we said, Python indexing starts at 0, right? So we actually have started at 0, But what we should have done is to, sorry, yeah, Python indexing starts at 0. So what we really want to do is to just, look at this again and say, okay, I want to increase this sum by 1. I want to add all the numbers, within 1 to 100, sorry, 1 to 10, right? So I look at this and say, okay, I have the first sum, which is 0. So I'm going to say 0 plus I, which is the first element in this range. The first element in this range is 0, but really what I want to do, I want to start from 1. So what that means is that I need to come here and ensure that this is I plus 1. That way, I start my addition from addition from 1 and not 0. And after the first pass, the sum of number becomes 1. If I go over the loop again, the I becomes 2, I becomes 1. And if I try to add 1 plus I plus 1, it adds 2 to that number, and it keeps just going over the loop. And eventually I'll get the correct thing, which is like 55. That's just basically a way of using accumulators. So if we look at the software carpentry lesson we're going through, there are a lot of other examples or other fun stuff we could try out just to get some practice on for loop. So I'm going to move on to conditional statements. Now, so for the for loops, right, we see that we were able to, for the for loops, we basically perform just one kind of function, or one kind of, we just performed one kind of function for all, entries in a loop. There are times where we want to, perform different functions. Like say, I want to just go through my list and just say something about each element in the list. I could use conditional statements to, do this. So the way I do this is just to say, okay, I could use like an if statement. The conditional statements we have in Python are if, else, if and else. And we also have while, but we're not going to look at while. So I could say if, say, depths. I want to create a function such that if the depths, if any depth in this our list of depths is greater than 500, we just say print huge depth, right? If it's less than, say, 300, we could say shallow. And if it's in between, we can say normal depths. So basically, all I just have to do is to call an if by saying if depth. Okay, let me just first do this like in a very simple way. I'm just going to say, just pick one depth as maybe 500. Then I can just write an if statement if depth is, say, greater than 300. Okay, if depth is greater than 500, I'll just make this 525. Then print let's just say print large depths. Else print shallow depths. So if I run this, because depth is greater than 500, it prints large depths. But if this condition is not true, say depth was actually like 350, it's going to print shallow depths. And that's just basically how the if statement runs. So what I'm going to do now is that I'm going to try to do this for each element in this list of depth, just combining what we did in for loop with an if statement. So basically what I'm just going to do here is just to say for depth in depth, right? Then I say if depth is greater than 500, then I can say print depth. I'm just going to copy this, just say print slash depth. Because I have more than one condition, I would use the if or else. I will use the else if. We write that in Python. We just else if depth is greater than 300, print normal depth. Then I could then the last one is just say else print shallow depth. Now, if I run this, because I have this depth list, if I run this, it's going to go through all the depth in this list and print either large, normal, or shallow. So it goes through the list and prints either large, normal, or shallow. But the problem with working like this is that we can easily run into errors. Like we can easily run into logical errors. If I had maybe put 300 first and put 500 here and run this, we'd see that it said shallow depth. Then for the rest, it does large depth, which is wrong. There's a logical error here. And that is because the way this conditional statement work is that it picks, once one condition is satisfied, it doesn't check the rest condition, right? That is why when we try to do these things, we ensure that our logic is correct. And to ensure that our logic is correct, we can either start by using the most restrictive case, which I did earlier by saying, okay, 500, then 300. This is very restrictive. That way it gives me the correct value. Or alternatively, I do the right thing, which is basically saying, specifying actual condition. If depth is greater than 300 and depth is also, less than 500, this is actually a better way of doing it. That way, I don't run into any logical errors. Then this is actually a better way of doing it because I have specified the upper and lower bound, right? I wouldn't run into errors trying to, run my program like this. So that's just basically how we can, do these kind of for loop with conditional statements. So again, I'm just going to run an example of another example of what I just did. So I have, for this one, I have a list of scores for students. Basically, if a student has score above 80, that's a B. Score above 93, that's an A. Score above 70, that's a C, and so on. So basically, I want to still, iterate over this, and I'm going to iterate over this, and I'll return, grades for each of this. So again, I'm going to say for maybe score in scores. Now, just a side note, I don't necessarily have to use score here because I'm talking about scores. I could actually use, say, for I in scores, that still works, right? If I is greater than 80, if I is greater than, say, 80, print B. and else if I it's greater than 70, print A, else if I is greater than 60, print oh sorry, if it's greater than 80, print B, if it's greater than 70, print C, and if it's greater than maybe 90, print A. Then let me just stop here and say else, just print print an F. Now, again, we'll see that if I run this, I'm going to run into problems because you see that nobody got an A here. And that's because one of the first condition it checked here was a B, and whenever 90 just exceeded B, it just printed B and that's it. It doesn't bother to check the other conditions. So again, we have to ensure that, you know, either we start with the most restrictive case by making this 90 and making this A, or making this 80 and making this B, or making this, then making this 70 and making this C. We can either, you know, start by, you know, doing this most restrictive case or doing, I would say doing the right thing, because, you know, doing it this way, you will never run into problem. That is to say, I'm going to say if I is greater than 80 and I is also less than 90, print B. If I is greater than 70 and I is also less than 80, print C. Yeah, so this is like a better way to put it. Then another thing that might occur is the fact that we might have somebody who just, you know, stays at 80, right? So if I run this, let's see what happens to the person who has a score of 80. Now we see that the person failed, right? But of course, this person has like a B. Now the reason for this is because in specifying our conditions, we have failed to make, you know, room for somebody who's for a score that's at that borderline. So to ensure that we don't have this kind of problem, instead of just using the greater than sign here, we say we use the greater or equal to. That way, we've said, okay, if somebody is either greater, if somebody is equal to or greater than 80, that way it would, you know, ensure that the person has a B. And I also do that for the, I'll also do that for, I would also do that for 70. That way it ensures that, you know, it captures people at this borderline, you know, by ensuring that this is a closed bound of, you know, it includes 80. You know, else we just, like we saw, you know, it just said the person that has 80 failed. And these are things we need to take notes when we try to write our conditional statement, because the simple question is 80 greater than 80? The answer is no, 80 is not greater than 80. So it returns a false and it doesn't execute the block of cell that we want to execute. So this is just another example of me just, you know, I was just playing around with, I have depth, I have a snow depth, I also have density, and I try to iterate over each, you know, each depth and density. Now this time I'm iterating over two different lists at the same time, right? So I'm just going to write this from scratch so you see what I was trying to do. So basically I'm going to say, again, I'm going to use just I. Now the reason I'm using I in this case is because this is not specular to either depth or density. For readability in other cases, I try to use for score in score, just because I want to, you know, make it more readable. So, but for here, I'm just going to use for I in range. Again, I'm going to use range. Then maybe length of depth, right? So for I in range, length of depth, I could either use depth or density because they are the same length, so it doesn't really matter. what I want to do here is that I'm going to look at a particular depth and a density. And if it reaches a particular threshold, I'm going to say, okay, that's a lot of ice and there's going to be a lot of water in there, right? If it doesn't, then I can say, okay, well, maybe little ice, not much water. I'm just going to specify specific conditions that this would fulfill. So the first condition is going to be if depth I say it's greater than a particular threshold, 2500, and density. So I'm iterating. I'm just doing this so we can see that we could iterate simultaneously over two different lists. Density I is say greater than, I'm going to use a threshold of 0.5. Then just say print a lot of ice, lots of ice, so much water. Just writing anything. Then I go to the next condition, else if. Now this time I'm going to restrict it to a particular bound. Else if we have depth, right? I greater than, say, 2300, and just like I did in the previous example, and depth I, it's less than, again, 2500, right? And density. So this example is just to show us that we can, specify more than one condition in a block, and density I is, say, greater than 0.3, and density I is less than, say, this time 0.5. Then just print average ice, average snow, average water content, right? Then finally, I'm just going to say, else, just print nothing to see here. Else, just print nothing to see here. So again, this example is just, so if I run this, what happens is that, okay, sorry, nothing to see here. Now, if I run this, it checks each of these conditions, and if for any time both values satisfy the condition, it's, prints out the statement I want, it to print. And again, the idea of this example is for us to see that we can actually specify more than one condition. Like I did here, I specified like 4 different conditions. If we like, we can also maybe change this to an or, depends on the kind of logic we're writing, and it's still going to work because it's just going to check if we have this or this, then, give us this value. And that's just basically how we could just use if conditionals and for loops, right? The key things to just note is that we have the iterator and we have what we want to iterate over. And for each condition, we have like what function we want it to, perform. Now, quickly, I'm going to move on to writing functions. Now, so far we have been able to, see how we can create lists. We have seen how we can loop over this list to perform a repetitive action. And I've also, gone ahead to like look at conditional statements. That is, helping us perform different actions to each element in this list. Next, we're going to look at functions. Now, I've already looked at some inbuilt functions. Katie has already showed us how to use inbuilt functions. But now we want to create our own functions. So one of the reasons why we want to create our own function is, of course, for usability, so that we can reuse these functions. So to create a function, basically all we just have to do is just to like use the def keyword. With the def keyword, we already let Python know that, okay, we're trying to create, a function. And I'm going to call this function maybe print greeting. And I would not give it any arguments. And basically what this function does is just to print, say, hello world. Hello world. Now, the next time I'm going to use this function, I'm not going to, the next time I want to print hello world, I would not have need for, writing it again. All I just need to do is just to, if I run this, all I just need to do is just to call that the function that does the hello world, that just, does that for me. And it prints this. It might not, make so much sense right now, but if we actually have like a bunch of things we want to do, it's a bunch of things we want to do, would see the usefulness of this function. So again, this is just a function that prints. Now, there are some times we want to retrieve a particular value from a function. Okay, so I'm going to write a function that returns a particular value, right? Like say I want to write a function that finds the average given any list. So this function, I'm going to define it and call it, say, average, or I'm going to say main calculator. Main calculator. I'm just going to call it calc. Now this function takes in as values numbers, any list of numbers. And what it does is that I'm going to define something in here, a variable called results. So what it does is that it will sum up the numbers, and then divide it by the length of the numbers, right? And then return results. So if I do this, right, and I have this list of numbers 1, 3, 4, 5, 6, I can easily call this main calc function and give it, just so we can see that how this can be different from this. I'll just call it my lists. I'm just going to call this my list. Then I could call this my lists. So basically I want it to calculate the mean of my list. And when I do that, it gives me the mean of this list. Just a good programming practice, of course, is to consider all possible scenarios. What if, for instance, this is an empty list, right? And I try to run this, it gives me an error, right? Because division by 0, because the length of this list is 0, and division by 0, it's it's not possible, right? So that is why the first thing I can do is to say, okay, I could look at this case and look at the possibility of having an empty list and just say, and first of all say, if length of lists, if length of number is, say, equivalent to 0, then I could print something, say the list is empty, right? Else else just return results. So if I run this, oh sorry, if I made a spelling error with length. So if I run this, right, it tells me the list is empty. Okay, so we see that we see an error here, local variable reference for assignment. I'm trying to return results, but because the list is empty, it didn't get to this part of the code and it could not see what result is, right? So I'm getting an error because I tried to return something that does not exist. So a better way, the correct way to do this is if length is greater than 0, I can either return okay. So because we have not looked at Boolean, I'm not going to do that. I can just say print instead. Instead of using the return, I can just instead say use print instead. Just so we don't confuse things. So yeah, and so I'm not sure why I'm having an error here. If
Evi, at the top, you could say result equals none or something like that.
Yeah, okay, yeah. So I can just do results. So so that I can just initially, yeah, thank you. I missed that. So I need to just initially make result none so that whenever it doesn't find results, it can just return none. My bad. So this way we ensure that we have covered all possible this way we ensure that we have covered all possible angles to finding the average of numbers using our inbuilt function. So what I'm going to do here now and next is I'm going to reuse this function that we use for grading. And this time I want to write a function that just grades students for me automatically. Now, because I'm always going to have to grade like different maybe courses, I don't want to always have to write this bunch of conditional statements every time, right? So I could just encapsulate all of this into a list, into a function by just saying def grader. And so whenever I give it a list of scores or whatever, then I indent this return. Okay, just to be. So again, I'm not okay. So this function basically called grader. It takes in a list of scores and it iterates over the score. And what it does is that it prints, the person's scores. So if I call this function grader, right, for any list of scores, it gives me, the result, the grade of, each of that score. This way, I don't have to repeat, I don't have to go through the process of writing the whole of this because I have a function called grader. I just call grader. If I have another list of scores, say 45, so say 85, 95, 67, 89, and 78, right? I'm going to call this score 2. I can also call my function grader on this score, and it will just automatically give me the grades of this score. So I don't have to go back writing all these conditional statements. So we can see how we can just from a list, start from a list, envelope a list into a loop, then take a loop, add conditional statements and envelope all of this into, writing a function. Now, because we're out of time, I'm just going to quickly look at, the fact that we can also have functions with multiple arguments. So this is just a simple function that calculates like BMI, given height, weight, and measurement. Now, what I've done here is that I've given it, different arguments that this function can take. So far, I've just been given just one argument, right? So I've given it different functions, this different arguments this function can take. So here it can take in height, it can take in weight. And I give it one more argument, which is basically the measurement system. And now that's because in calculating BMI, some people might want to use kilogram and meters, some people might want to use pounds and inches. So I have like this default argument for measurement system, which I set to imperial, right? Again, I'm going to just do if the measurement system is equal to metrics, use this formula here, right? BMI will be equal to weight divided by height, else it's imperial, which is, the hard-coded system, then use this one, which is pounds, inches times 703. These are just given formulas. So if I try to print BMI, given a height in meters and kilogram, that means it's metric. I can specify what metric is here. And when I run this, I'm just going to run this. When I run this, it gives me the BMI of this person. I could also, if I was given the height in inches and the weight in pounds, because this is the imperial system, and I don't need to specify this anymore, right? Because it's already the default argument, right? I can just, print this and it gives me the value, right? So a function is a really cool way of just, trying to, reuse your logic or some piece of code you have written without having to write them from scratch every time you want to run it. So there are a lot of other, from the software carpentry page, we can see a lot of other use case we can see a lot of other, we can see things we can play with. If we want to just, get a hang of this, we can play with these other questions and see, what it's just to get our hands on this. So same thing for the lists, the loops, and the conditional statements. So if we have any question, we could just throw them in the chats, and any of the helpers can just answer that. Okay, I can see some questions here on the Slack. Are there any difference between sort steps and, okay, I think that has already been answered. Yeah, that has already been answered. Then okay, so where was depth? I see one question, where was depth defined? Like I said, the reason I use this depth here is just for readability. We could basically use or let me use anything. We could use anything, but I just have to make sure that I'm comparing anything and not depth, right? The reason I use depth, and it will still give me the value. The reason I use depth is because it's just for readability, just to make it easier to understand what I'm iterating over. So that same thing I did for score. I just say for score in scores. I could basically say for I in scores, I could just basically use anything in scores. Yeah, so that's why I did that. So do we have any other question? Okay, if we don't have any other question, I think I will turn it over to Scott or Anthony.
Sounds good. Yeah, I think,
Yeah.
no, it's perfect on timing. So thanks again, Evi and Katie, so much for leading these tutorials today. It's a lot of time out of your schedule, so really appreciate it. And thanks everyone for attending this session. Like we said at the beginning, it's a whirlwind tour, and I think you've got a great start here if you want to keep going with these Python tutorials on your own time. And now that everyone is on the Slack for SnowEx Hackweek, just as we're getting ready here in the next month leading up to the event, don't be shy. You know, if you have questions going over this material, especially some of the topics we didn't get a chance to cover, you're welcome to keep using that Slack workspace to ask questions. So that can either be in we have a Hack Week channel or the Software Carpentry questions channel. And like I said earlier, it's really you know, a space where we want not only the instructors of this event, but also participants helping one another and answering any questions you have the answer to. So please do participate there. And the recording for this will post in the next couple of days here as well. But yeah, thanks again for attending, and really looking forward to the Hack Week coming up in a few weeks.